Good morning, good afternoon, good evening from where are you tuning in. I'm so excited to talk to you about why you should contract test your microservices here at Python WebMonth 2023. Our agenda is going to be pretty tight today. We're talking about a bit about microservices. How does contract testing works? How does it fare against our traditional testing mechanisms? What is the role of Pact.io in contract testing? And then there will be some closing thoughts. Before we jump into the content, who am I? So, like I said, Syed Dawoud Sheraz. I'm a software engineer at Arbisoft, Lahore, Pakistan. Uh, I am primarily a Python and Django developer, but I have worked with React and Redux on industry level as well. Uh, Let me tell you a bit about Arbisoft. So, Arbisoft is mainly a contractor or service provider company in Pakistan. It's like one of the leading names there. As part of Arbisoft team, I've been working with Alex and Tuyo since 2018. And besides that, I have also worked with some internal products development at Arbisoft. Here are a few links on my GitHub, Medium, LinkedIn, if you want to get in touch with me. Right. So with that out of picture, let's jump right into our content. So what are microservices? So traditional web application development would follow the monolith approach. So whenever a new product or project would launch, there will be one single code base. All of the code will be added there. All of the people will be committing their code in that single application. And as the time would go on, that application will grow in size in terms of code and in terms of people as well. Monolith approach like works really good for starting an application, but when an application grows and it expands, it tends to get into issues of like maintenance, testability, deployment. So to avoid those challenges, a microservices architecture was introduced. The idea behind microservice architecture is that instead of having a giant monolith, we'll have a number of small size applications that will be maintained uh, independently via different teams. They will be deployed independently and would communicate with each other via API calls or messages to exchange information. And that communication is like the key part in microservices architecture. There are uh, quite a lot of industry giants that are using microservices architecture. Over the last decade, Netflix has like emerged as a microservices key player in terms of scaling and providing their streaming content to millions of users out there. OpenEdX is an example because I've been working with edX closely, so I have seen the magic of moving from monolith to microservices. So even though microservices solve a lot of challenges, like it made applications small in size, the deployment was made independent from each other. They would not be like blocking of other teams on your work. Yes, there were positives, but there were also negatives. Because microservices are communicating with each other and sharing information, that increase the complexity of communication. That communication can be via API calls or via events or via messages. And that in turn led to integration related challenges. What sort of challenges? Here's quite a recent tweet by Elon Musk on March 6th, right before this conference time, and I got to use this. So a small API change had massive ramification. The code stack is extremely brittle for no good reason, would ultimately need a complete rewrite. So what Elon is saying is that in some service, an API was changed, and that API change caused problems with other services. And Twitter is no exception for that. In microservice architecture, that is like a problem that since we are, when we are testing APIs or unit testing APIs, we tend to mock the clients or utility that we have written for API testing. So let's say on front end, we might have some utility that is using Axios or some other tool to hit a backend API. get some response, and then pass to our component or some other utility function. Uh, in unit test, we'll mock that, but if something were to change on backend, we would not know about that. And that is something that contract testing uh, hopes to get rid of. So I have talked about like contract testing, said it a few times. So what is it? Uh, Sharing the definition from Pact.io, contract test asserts that inter-application messages conform to a shared understanding that is documented in a contract. Without contract testing, the only way to ensure that applications will work correctly together is by using expensive and brittle integration tests. So I have highlighted a few words here like inter-application messages, shared understanding. So inter-application messages, like we have multiple applications, shared understanding mean that uh, how the applications are used, there is a shared understanding between both services documented in a contract, meaning we have some sort of file or contract where this understanding is documented. And we essentially want to check that application will work correctly together. Another way to take a look at this, contract testing is a technique for testing an integration point by checking each application in isolation to ensure that messages it sends or receives conform to a shared understanding that is documented in a contract. So in this definition, again, we are seeing the words like shared understanding documented in a contract, integration point. So the idea behind contract testing is that since two applications are communicating with each other and they are sharing messages with each other, that communication is like the key point in making sure that those applications work correctly together. And just like we do unit testing and E2E testing, we want to ensure that that integration linkage between those applications work as expected. What sort of message types can we expect? So in terms of HTTP, we have HTTP requests and responses. In terms of queue or event-driven architecture or practices, we'll have events or messages that are appended to the queues. A bit of visuals to try to set a base for like what essentially is something that will contract testing do. So we'll have two applications. One is provider and one is consumer. Provider is something that is providing the functionality, be it in form of API or messages. Consumer is someone that is utilizing the API for its own usage. So on left side, we have a provider API response that is like returning us 6 fields: name, age, city, gender, active, and country. Our consumer is only interested in name and age. Name should be a string and age should be an integer. So what contract test will do is that they will assert that the consumer's requirement, that is name and age, name in string and age in integer, that should be provided by the provider. It does not care about the other fields that are being returned by the provider. So provider can remove country, provider can remove active. It will not affect consumer. For consumer, these two fields are like key component for its working. So if the provider were to change age from integer to string, that would be a violation of contract, and that is something the contract test will flag on our PR level. So there are a few terms that to have already used and that there will be continued along the slides. So the first two major terms are consumer and provider. Like mentioned earlier, that consumer is an application or service that uses data or functionality from another service. That data or functionality can be in terms of just fetching information or performing some sort of operations on another service. In terms of HTTP, it's the application that initiates the request. In terms of queues or events, it's the application that is reading from queue or receiving the events. Provider is on the opposite side of spectrum. It's the application or service that provides the data or functionality for another service to consume. So for HTTP, it's the application that returns the response. In queues and events, is the application writing the queue or sending the event. What sort of consumer provider can be? So we can have backend to backend communication to backend applications. One would be consumer or provider. We can have mobile app as a consumer using the APIs from backend. So in that case, our application will be consumer and the backend is provider. Our single page application or React only applications that are a good example of consumer where they are using the backend APIs to power the behavior of their single page application. An application can be both consumer and provider depending on the context. So it's fairly normal for that. And for queue, it's like application writing. So the queue is provider and the application reading from queue is our consumer. What is interaction? So if I were to go back to this example, consumer is only interested in name and age. So if consumer were to hit provider's account API, it expects name and age to be there. So an interaction is composed of two things: the request that is made by the consumer and the minimal expected response by the provider that contains the data that consumer requested or consumer needs. So in terms of interaction, our interaction will register that, okay, if I hit provider's account API, I expect name and age fields to be there. That will be documented in an interaction. A contract is just a collection of all the interactions that are happening between a provider and a consumer. So a consumer might be using one API, a consumer might be using multiple APIs. It could be using one API in different contexts. Contract will contain all of those interactions, and each interaction in the contract is unique and independent from other interactions in that contract. So with that, we have established the base term that will be synced and the basic idea of like what is contract testing. Now we'll jump into consumer-driven contract testing. Contract testing, there are mainly two types. One is consumer-driven and second is provider-driven. Consumer-driven is the one that is used a lot and is popular, so that's why I'm focusing on this. So in consumer-driven contract testing, it's essentially two-step process. In the first step, our contract or pact is created by the consumer application that contains the interaction with the provider application. And in the second step, those interactions from the contract are replayed against a provider service, and the response from the provider is compared with the response that we have in the interaction. And if the responses match, we'll know that interaction is valid. So the first part, which is like generating the contract, which is done as part of consumer test. So normally when we test out the API related stuff in our unit test, what we do is that we'll mock those clients or utility function. So we'll have some sort of client that makes a request and returns the response, and then we'll have some other utility or other component that acts against that response. The consumer test part is essentially the same. So if we're talking about in Python, if we are mocking the request caused by responses or via mock.patch, here we are doing essentially the same, but with a different mechanism. We are registering those mocks in the form of interactions. In the unit test, whenever those are run, we make a real request to that mock service. The mock service will return us our predefined response, and then we'll do our regular processing on that return response and see how our unit test behaves. That part of generating the contract or in consumer test is like same to how we do in traditional API related tests in our services. The difference here is that when these tests are run, we'll get an output, which will be in the form of a contract. So let's say if we have like 10 different use cases that have been mocked, we'll get a contract that will contain all of those interactions. And each interaction will have the information of like uh, what is the URL that we are hitting, what is the request type, what response are we expecting. And this information, it will also test the unit test stuff, but it will provide us a contract that will contain those interaction details. So once we have that contract, we'll verify that contract against provider service. So the second part is we'll take that contract, we'll take each interaction, and remember in interaction, we'll have the URL of the provider that is hit by the consumer. So we'll take the URL from that interaction, hit it against a actual provider, and see the response that is returned by the provider. We'll verify the response returned by provider with that we have in interaction. And if everything matches, we'll know that interaction is valid. And once all of the interactions have been replayed successfully and there is no violation, we'll know that our contract has been verified. So if we were to bring it all together, the idea behind consumer-driven contract testing is that we'll write consumer unit test. The output of consumer unit test will be a contract. That contract will have all the interactions that will be replayed against a provider, and then we'll verify the response returned by the provider with the interactions that we have in contract. And if everything matches, we know that our contract is verified. And one really great thing about these consumer unit tests is that they run as part of our regular CI unit test. So we don't need a dedicated pipeline to run these tests. They can be integrated within our unit test pipeline. But for like verifying the contract against provider, we do need some sort of CI. That is something we'll discuss in the upcoming slides. With that said, when should we contract test? Right? Ideally, if we have two or more services that are communicating with each other, our criteria for contract testing is essentially fulfilled. But setting up contract testing workflow is a bit tedious for the first time. So ideally, if we can do it rather early in our application scaling phases, it will be easy to onboard other applications as they are being developed. But coming back to like, why is there need for contract testing in microservices? What makes them so special? So as mentioned in that slide at start of the talk, that integration and communication is the key for microservices architecture. The exchange of information that is happening via API calls or via messages, that is what holds our microservices architecture together. If any of the communication linkage breaks between the services, that breakage will essentially ripple to our entire ecosystem, just like we saw with the case of tweet that Elon had put. So how do we traditionally test those integration? We have E2E or UI level integration test that perform this job. But to do that, we need to have a complete infrastructure that is set up that contains all of the service, and we test each and every scenario there. That setting up the infrastructure part is expensive, especially for the system that have like a lot of microservices. Each microservice will need some sort of infrastructure, and infrastructure even on the cloud comes with its own cost. And again, even if it's for the testing purposes, there will be some cost involved with that. And that is the main challenge with infrastructure setup, that it is expensive in both time and resources, and we are overachieving stuff with that. So for instance, when we install some smoke detection alarm in our houses or workspaces, we don't set our house or office on fire to test that. There's some sort of button, or we expect that, okay, when there is smoke, the alarm will work. And that is something that we want to test with microservices, that we should not be needing an entire infrastructure or production level infrastructure just to test our integration. We should be able to do it in a better way. Also, most important, we want to find these integration failures rather very early in our deployment and deployment pipeline. So ideally, when we make our changes, we have a suite of CI tests that are running on our pull request. And if our change is something that will break our flow, we get an instant feedback in the form of some sort of test fail. We are doing that for unit test. We should be doing that for our integration test as well, or our integration structure as well. We should not be learning about that rather at the end of pipeline. So typically, we'll have some sort of infrastructure setup and our E2E test will run at the end of pipeline. And then we'll have some sort of mechanism. It depends if you have that mechanism, which will inform the developers on our PR or some sort of alerting that our integration has failed. So ideally, on our PR level, we should be learning if there is some sort of integration failure. And that is what contract testing is achieving. That, like unit test, we'll get our instant feedback if our integration is failing because of the change that we are making. How is it different from our unit and E2E testing? So unit test, they verify individual module and units, even the smallest level of code. We tend to get maximum coverage with unit test. We like test each and every scenario, verify the side effects. But one really great thing about unit test is that they are uh, fast. They execute really fast. We'll have hundreds and hundreds of unit tests, and they will rather run very fast on our GitHub Actions or Travis, whatever the CS service that we are using. On the opposite side of spectrum, we have E2E tests that involve multiple applications, multiple services, and we test a complete user flow end to end. And that will involve like jumping between different services. The big catch with E2E tests that apart from time consuming, they are prone to flakiness, especially when the UI is involved. Contract tests are in a special case that they sit in middle of our testing pyramid and they take benefits from both unit and integration, our unit and E2 test. They run fast like unit test and they help verify the integration like we do with E2 test. They are not flaky because we have defined our expectations in terms of the requests and responses that we have, and they're easy to write, easy to maintain as compared to E2E, whose effort like scale exponentially. With that established, that all this idea of contract testing, like generating a contract via unit test and verifying that against a provider, sounds very cool on the paper, but how do we achieve that actually? Like, how can we write the test that will give us contract? How can we replay that contract against a provider? And essentially, how can we automate that on our scale level? There should be some sort of tool for that. And Pact.io is one of the famous tools out there for this purposes. Uh, it is an open source tool for testing our HTTP or event-driven communication in web apps. And what's great is that it has a lot of tools and native libraries that essentially help with writing consumer test, helping with writing our provider verification, and providing the tools and application that will essentially automate the entire CI flow that we have just discussed. So they have libraries like Pact Python, Pact JS, Pact Ruby, Swift, C++, etc. for writing those consumer tests or provider verification. And then they have the applications like Pact Broker or PactStore.io that essentially help bridge this consumer and provider flow. So, for instance, we have an example of PactPython. This is the code from the sample code that Pact has on their one of their repos. we'll focus on this test get product part. So we have some sort of application where we are getting product details. So you can see we have already defined an expected response where we are expecting the ID, name, and type. This expected response will be there for the API level mocking that we do in normal unit tests. The difference in is here is like how we register that interaction and what sort of response are we expecting. So with Pact, we'll have these few lines is like how the interaction is registered. So given the Pact object, the given is state maintenance, like what should be the state. So we are expecting that a product with ID 10 should be present in our provider. So when we get a request to get a product, what will be the request? It will be a GET request against this URL. When we receive that request, the Pact should respond with 200, but meaning okay, and this should be the body. So this is something that we'll mock in our regular unit test as well, that will mock this via responses or Python's mock path utility. And what we'll do is that we'll call our client that is responsible for getting the that making the API call and getting the information, and then we'll just assert against that response. That part is pretty much similar to how we'll do with the regular API testing, but what Pact will do is that Pact will maintain this interaction and output this in the form of a contract. The same flow will be done with Pact.js as well. So if you are writing tests with jest and enzyme, you can see the syntax is quite similar. So we'll have a mocked service where we're defining our state, what sort of requests we are getting, what's the URL, the headers, and how should we respond against that request? It should be 200, what should be the body? And then we essentially mock assert against that response. That part is the consumer test, and when they will run, we'll get a contract. On the other spectrum, which is provider verification. So remember we talked that in provider verification, we'll replay each interaction against a provider service, and we'll compare the response of the provider with that we have in our contract. Pact comes with built-in tools that will handle this internally. We just need to pass the URL of like, where is the contract? How should we set up our DB, the provider state concept? So the idea that a product with ID 10, we should be setting that up in our provider when we are running provider verification. So for that, we'll need to provide a provider setup URL, our contract URL, and some other configuration. Pact has a lot of stuff there. But once we provide those attributes, Pact will handle this internally. We will not need to write the utility that like read the contract and make those requests. We just need to give the URL of Pact or our broker and some other environment related variables, and it will handle all of the stuff internally. What role does Pact Broker play in that? So when we get a contract from consumer test, we can keep that contract in our repository, or we can also publish it to Pact Broker, which is an open source application developed by Pact maintainers. The great thing about Pact Broker is that it will contain the information of the contract, what is the version of our consumer, what is the version of our provider, and it will maintain the history, like which version of consumer is compatible with which other version of the provider. And it also detects if the contract has actually changed. So it is using hashing to see if the contract is actually changed, and if the contract has not changed, it will just give the previous verification result if the contract was like valid or not. One great thing is that there are built-in webhooks. So whenever a contract is published or the verification results are published, there are webhooks in Pact Broker, and against those webhooks, we can do certain actions. So let's say when a consumer publishes a contract, we want to verify that contract against a provider. So we can configure a webhook for that. So whenever a contract is published, we can trigger a new build on Travis or on GitHub Actions to start that verification flow on the provider. And this webhook that it provides, this makes the setup of CI really easy. And this is like one of the reasons that, that the setup of CI of contract testing becomes seamless with Pact Broker. So this will be the UI of the Pact Broker. Will have the details of consumer applications, provider application, when was the loss that Pact published, or like when was it verified, or if it was verified in the first place. The contract can be seen here as well, or all of the interaction will be visible there. Pactflow.io is a commercial version of Pact Broker, which is not an open source. It builds upon the functionality that is provided by Pact Broker and includes some more features such as storing secrets for the webhooks to use, better UI and UX, user account and role management. So one like big drawback with Pact Broker is that there is no user management there. So if you're using Pact Broker, you'll have to like move it behind some sort of VPN so that it's not publicly accessible. With Pact Flow, we do get our user and role management. And like it also maintains the audit logs of like when was the consumer, provider, or contract change. Its UI is different from Pact Broker, so you can see it here. It's housing detail of consumer version, provider version, when was the contract verified, when was it published. Another great thing about both Paxflow and Pact Broker is that it maintains a network diagram of the services. So let's say if we have our full service that is communicating with bar and before, there will be network diagram for full that is showing like which services it is communicating. And like one challenge that I have seen with onboarding a new engineer on microservice architecture ecosystem is that it is very difficult to explain to them like which services are dependent upon services that we own. There will be some sort of documentation and service metadata repository, but there is no visual queue to maintain those stuff in automated fashion. And that is something that Paxflow or Broker will do for us automatically. And that's like really great in terms of onboarding other folks as well, like how important is our application in the entire ecosystem. So connecting it all together, we'll write some sort of consumer test with our desired Pact native library that will generate a contract or Pact. We'll write provider verification on our provider side, and then using Pact Broker or Pact Flow, we'll set up our CI. So our CI can trigger provider flow when our contract is updated, or verify the contract whenever we make some changes on our provider side. So essentially we'll need two jobs, one on consumer and one on provider. On consumer side, we want to know that if we have updated a contract, it should be valid against that provider. And on the provider side, whenever a provider is updated, we want to ensure that all of the contracts of that provider are valid. And that is something that we can do on CI level with Paxflow and Pact Broker, and with the entire Paxflow as a whole. Phew, we are at the end, and a bit of closing thoughts on this. I can say that like it was quite theoretical, and I did not delve in much into the coding aspects. The idea is that it is a fairly new concept. Like we have seen like industry adopting it over the last decade, but it's still not like used to that scale. So contract testing is not a substitute for good team level communication. So we cannot just like jump into contract testing and write a contract and let other teams know that they should write a verification or write a verification for the service. We should get in touch with the other teams who own the services that our services like communicating, and establish the understanding that we should be doing the contract testing to ensure that integration is working as expected. It is not functional testing of provider. So if I were to jump back to the original definition of contract testing, we want to ensure that application will work correctly together. We are just focused on that. Consumer should not be like functional testing the provider, like verifying if I send incorrect uh, data, what would the response of provider. Only those items or those interactions that a consumer actually needs, that is something that contract testing will test. So if you're on a consumer side, list down what services in the ecosystem that are consumed by your service. Or if you're a provider, understand which application are consuming the services that your application is providing. Establish an understanding with the teams, understand which APIs or which messages are like used for the communication, and then write consumer test, provider verification, and then essentially develop the entire CI flow using Pact, or there are some other tools like Spring Boot. Well, I can't remember the exact name. To learn more about Pact and how to use Pact for contract testing, I'll highly recommend that you join Pact Foundation Slack. They have like really great active community, and they are looking for support to extend the libraries that they have. And for our team, when we started on contract testing back in 2021, we had limited resources available online. Even Pact documentation at that point was not very up to date. So we joined their Slack and we got in touch with the maintainers to learn more and what we were doing wrong and what we were doing right. And with the active feedback, they also improved their documentation, and we were also able to set up this entire flow for our services. So in that team, it was me and two junior resources. They had like less than 2 years of experience in the industry. So it was quite a daunting task for us, but for with the help of Pact community, we were able to achieve that. So I'll highly recommend, if you are interested in contract testing and have faced the integration challenges, they have a really great community and can help you with a lot of stuff uh, in setting up the entire ecosystem of contract testing. I have uploaded my slides on my GitHub and they should be available on Logswarm as well. These two talks by Beth Scurry, she is the co-founder of Pact. I recommend that you should watch these talks. This talk is also inspired from these two talks, and where she has like delved deep into the entire and system of like contract testing, how the idea came to be, and like why it's important in microservices. Thank you very much, and I'll highly appreciate your feedback. Like, what could have been improved in this talk? What did you like? Was it too much on the content side? And yeah, I'll be happy to answer any question that you have face to face. Thank you.